NASA plans to build a base on the moon before sending humans to Mars to shorten the journey. SpaceX founder Elon Musk wants to win the race to reach Mars. Additionally, European and Russian space agencies also have plans to send humans to Mars. But how will humans survive after landing in Mars' harsh atmosphere? Unlike Earth, Mars lacks oxygen, the most essential need for life. What method has NASA found to produce oxygen on Mars and the International Space Station? Why won't the method used on the ISS work on Mars? There are many reasons behind humans' desire to live on Mars, including scientific exploration and space curiosity, but there is also a sense of compulsion or fear. The human race may go extinct due to some disaster on Earth, as dinosaurs were wiped out 65 million years ago. This fear is further fueled by climate change on Earth. This is probably the biggest reason that, in the future, someone may become the Neil Armstrong of Mars. Elon Musk originally intended to land on Mars in 2026, but he has now predicted 2029 for the first human landing. NASA also plans to send humans to Mars. But the question is not who will go to Mars first. The real question is, how will humans survive after reaching Mars? Of course, many properties of Mars are similar to Earth's. The length of one day on Mars, also called a sol, is only 39 minutes longer than a day on Earth. There are different seasons on Mars as well as on Earth. Additionally, there are ice caps at the poles of both Earth and Mars. Earth also has an atmosphere, and Mars has one too, although it is thin. But one thing that is absolutely insufficient for humans to live on Mars is oxygen. So how will oxygen be produced on Mars? Not just for one or two people, but to sustain an entire colony. When we think about keeping humans alive in extreme conditions, the first thing that comes to mind is the ISS, the International Space Station. For 25 years, the ISS has been continuously producing and providing oxygen and fresh water to humans in every condition of space. There are always 4 to 5 astronauts on the islands, whose daily water requirement is at least 45 liters. That's 1,350 liters per month and 16,200 liters per year. Additionally, 1,000 kilograms of oxygen gas is used annually on the ISS. How is so much water and oxygen produced 400 kilometers away from Earth? The ISS uses 2 systems for this purpose: the Water Reclamation System, WRS, and the Oxygen Generation System, OGS. But why can't we install both these systems on Mars? To understand this, we first need to know how these systems work. The Water Reclamation System collects water from human waste, such as urine, sweat, and humidity, then cleans it to make it drinkable again. Astronaut Douglas Wheelock once said that their coffee for the next day is made from yesterday's coffee. The WRS system purifies the water already present in the ISS and makes it reusable, saving 91% of the water from being wasted. Next is the Oxygen Generation System. This system takes a little water from the WRS and then produces oxygen for breathing through a process called electrolysis, which we learned about in 5th grade. Electrical current is passed through water, splitting it into oxygen gas and hydrogen gas. Oxygen is used for breathing, but hydrogen is a highly dangerous and flammable gas that could burn the entire ISS in seconds, turning it into a fireball. However, this hydrogen gas is not wasted. Instead, it's put into another system called the Sabatier system. This system collects the waste carbon dioxide from astronauts on the ISS, mixes it with hydrogen gas, and produces water, methane gas, and a little heat. The water is reused, and the heat is put into the heat management system. But methane gas, which is very important on Earth, is released into space. Methane gas, a type of fuel, can be used to produce energy and heat, but it's wasted on the ISS because oxygen is needed to burn it, and oxygen is the most valuable gas there. If we look at the entire process of oxygen and water production on the ISS, it depends on refueling missions. Although it's very efficient, there are losses and leakages in every system. That's why water and oxygen are brought from Earth every 6 months or a year and replenished on the ISS. These refueling missions are very costly. Transporting just 1 liter of water 400 kilometers up to the ISS costs more than $2,500. Therefore, producing oxygen in this way on Mars, which is 225 million kilometers away, is not cost-effective. We'll need a system that uses resources already present on Mars to make oxygen. In 2021, NASA's Perseverance rover was sent to Mars. A device was installed in it for this experiment, named MOXIE, or Mars Oxygen In Situ Resource Utilization Experiment. Unlike the ISS, where water is sourced from refueling missions, finding water on Mars would require drilling several feet down to extract ice. For this reason, MOXIE uses carbon dioxide from Mars' atmosphere to make oxygen. Simply put, Mars' atmosphere contains 95% carbon dioxide. MOXIE pumps carbon dioxide from the outer atmosphere, pressurizes it, then puts it into an electrolyzer and heats it to 800 degrees Celsius, which separates the oxygen gas from the carbon dioxide. This electrolyzer is made of gold because gold is an excellent heat conductor, protecting other parts of the Perseverance rover from heat. In this process, carbon dioxide produces both oxygen gas and carbon monoxide. The downside is that if the carbon is completely separated in this process, it can form a layer of carbon, similar to the layer seen at the bottom of a cooking pan, which could harm the Perseverance rover over time. That's why this process is performed with great caution. But how much oxygen does MOXIE produce at a time on Mars? MOXIE requires a lot of energy for this process, so NASA runs it only occasionally, when there's extra energy left from the solar panel. So far, it has produced only 122 grams of oxygen, enough to keep one person alive for only 3.5 hours. To produce enough oxygen on Mars for a larger group, a bigger version of MOXIE would be needed, along with a larger power plant to run it. And this is the biggest challenge so far. Now, to understand the situation, MOXIE first compresses carbon dioxide with a compressor, then heats it to 800 degrees Celsius. Both these processes require a lot of energy. To solve this problem, scientists are working on future technology that could break the carbon dioxide molecule at a lower temperature. In this method, oxygen molecules would be separated from carbon dioxide not by heating but by creating vibrations inside the molecule. This technology has been tested in the lab, but due to the high atmospheric pressure and temperature on Earth, it's not possible to conduct this experiment here. However, the atmosphere of Mars is perfect for this work. Whatever the technology, our goal is to make oxygen on Mars using materials already present there. The devices that make this oxygen should not be dependent on Earth, because the ISS is only 400 kilometers away from Earth. If the oxygen generation system there gets damaged, sending the astronauts back isn't a big issue. They can wear their emergency suits, wait for refueling for a few hours, and even return to Earth. But if, after colonization on Mars, the oxygen generation machine fails, there won't be an option for refueling, nor will it be easy to return to Earth. We hope you enjoyed this video. Please like and share it. Thank you very much for your supportive comments. See you in the next amazing video.